We've turned text into vectors, addresses on a map of meaning, and we said similar things sit close together. But close is a human word. A computer needs an actual number. So today we answer the question that makes search possible. How do you measure how similar two vectors are? Get this, and you understand the search in semantic search. Welcome back to AI in 5. Start with the simple intuition. On a map, two cities that are physically close are, well, near each other. Same thing here. Two vectors that sit close together in meaning space have similar meanings. Two that sit far apart have different meanings. So measuring similarity is really just measuring distance or closeness between points. The computer turns related into a number it can compare. Now, you might say, just measure the straight line distance between the points, easy. And you can. But there's a catch. Longer pieces of text can produce vectors that are bigger in size, which can throw off a plain distance measurement, even when the meaning is similar. What we really care about isn't how long the vectors are. It's whether they point the same way. That's why the most popular measure is cosine similarity. Forget the formula. Here's the plain idea. Imagine each vector as an arrow from the center. Cosine similarity just asks, are these two arrows pointing in the same direction? Same direction means very similar meaning. A right angle means unrelated. Opposite directions mean opposite meaning. It measures the angle between ideas, ignoring their size. And it gives you a tidy score, usually between 0 and 1. A score near 1 means the arrows point almost the same way, so the meanings are very similar, a strong match. A score near 0 means they're basically perpendicular, unrelated topics. So dog and puppy might score way up near 1, while dog and tax return scores down near 0. One clean number for relatedness. So here's how search actually uses this. You take the user's question vector and compare it against every document chunk vector, getting a similarity score for each. Then you simply sort them, highest score first. The chunks at the top, the nearest neighbors to your question, are the most relevant. Those are exactly the passages a RAG system grabs to answer with. Search becomes sorting by similarity. And you don't hand the model every match. That would be overwhelming and expensive. You take just the top few, often called the top K, where K might be 3 or 5. Enough relevant context to answer well, without burying the model or your token budget under a mountain of text. Find the closest few and stop. Quality over quantity. Step back and admire the trick. We took relevance, a fuzzy human judgment, and turned it into a number a computer can rank in milliseconds across millions of items. That's the entire engine of semantic search. No keyword matching, no guessing, just which stored meanings point most in the same direction as your question. Simple idea, enormous payoff. So vector similarity, often cosine similarity, measures how closely two meanings align, and the nearest neighbors are your best matches. But comparing a question against millions of vectors instantly takes a special kind of storage. Tomorrow, we meet the tool built exactly for that job, the vector database. See you tomorrow on AI in 5.